So we're going to use this video to help you review how to graph. So we're going to be graphing quadratics, right? So quadratics means that the highest exponent or the degree of this polynomial is going to be 2. So that's why you see the highest exponent here be 2. So we're only going to be graphing on this video this specific format, which is your ax squared plus or minus your constant. So whatever your constant is for each of the problems. So every time you have a situation like this where you don't have the bx, because usually your quadratics are ax squared plus your bx plus your c, we're going to be using a t-table to help us find some points so that we can graph these quadratics. So let's do a little review what role your a has. So the a will determine if your parabola opens up or down. And parabola is just the graph that we get. And it looks like a U like you see here. So if your a is positive, so if it's a positive number like 7, 9, whatever positive number, it's going to open up. Now if your a is negative, then it's going to open down. So just by looking at each equation, you'll know if your parabola opens up or if it opens down. The c, that constant, that number without the variable next to it, is your y-intercept. So let's take a look at this function here. So we have f of x equals x squared plus 5. And if we identify the a here, a is going to be 1, which means that is positive. Hence, the parabola is going to open up. So it's going to look like a U instead of like a rainbow. So it's good to identify these little parts here so that when you graph your points, you know if you did it correctly. So our vertex is 0, 5. So since your parabola opens up, the vertex is going to be the lowest point. The vertex is a point on the parabola that's in the middle. So we have this function here. We have those x values. We always use the same x values. So it's going to be -2, -1, 0, 1, and 2. So we're going to start with -2 here. We'll plug in -2 to the equation. Everywhere we see x, we're going to plug in -2. And then we'll solve to get an actual value for our x coordinate. So I'm just copying everything in my equation. The only thing I'm changing is instead of x, I'm going to be using -2. F of x, -2 there, that's just part of the notation. We don't do with anything with the f and the -2. What we solve is what's f on to the right side of the equation. So PEMDAS says to do x1 is first, so that's why we're going to do -2 to the second power. -2 times -2 is 4, and we still have the plus 5. Add those two numbers together, we get 9. So the first point that we have is going to be -2, comma 9. So that was our y-coordinate. So we do all this solving to get the y-coordinate of the points that we plot for our parabola. We'll do the same thing with the other values here. So now let's work with -1. So again, I'm just going to copy everything in my equation. The only thing I'm going to change is instead of using x, we're going to use -1. And we'll follow PEMDAS. So PEMDAS says to do x1 is first. So we're going to do -1 to the second power, which is -1 times -1 gives you +1. All these numbers, when you square them, you're going to get a positive. And then we add those two numbers together, we get 6. So the y-coordinate for this point is going to be 6. So our x was -1, so -1, comma 6 is our second point. We would normally do the same thing with the 0, but in the information, the problem tells us what the y value is, which is 5. So the vertex, we didn't have to do any work here. We're just going to use that point since it's the same x value. Let's go ahead and now plug in +1 to our equation. So substitute -1 everywhere we see x. I mean +1 since we're doing +1 now. We already did -1. All right, PEMDAS x1 is first. That's an easy one. 1 to the second power is just 1. And then add it to the 5, and we get 6 again. So our fourth point would be +1, comma 6. And as you're doing this, look for patterns. Maybe we find something, a certain pattern, so that we don't have to do every work. You always want to look for shortcuts in math. So let's plug in positive 2 now. Follow our good old PEMDAS that says to do exponents first. So 2 to the second power is 4. And we're going to add the 5 to it, and we get 9 once again. So I have my 5 points that I'm going to graph in my parabola. I have the vertex, which the problem told us that it was at 0, 5. So let's go ahead and start scaling our y-axis and our x-axis. So our x-axis is that vertical line. And let's be strategic where we place the x-axis. So since my smallest y value is 5, I'm going to put my x-axis out all the way at the bottom. And we only have 4 values for x, so we're just going to cut them, spread them out. That way we don't have like our graph in this little tiny space. So that's why I skipped 3 boxes, just to spread out the x values. The y values, our highest y value on here, let's take a look, it's 9. So let me just skip 2 boxes for each and go by ones. Again, the reason why is just preference. Since I don't want my graph to be in this little tiny space, I like to spread it out. So we're going to go by 2s, and we went all the way to 9, which was the highest y value I was going to graph. I usually start with my vertex, which was at 0, 5. So I'm going to go to 0, 5 right there. And it opened up, so that means that's going to be the lowest point. At 2, it was 9. At 1, it was positive 6, so closer to the vertex. And at 1, it was also positive 6. And at 2, it was also 9. So remember what I said, our parabola looks like a U. So we're going to connect these points with the curve so that it looks like a U rather than a V. Because if you just connect them straight from one point to another, it's going to look like a V. And that's a different type of graph here. That's for absolute value functions. Okay, so let's see if we can find some patterns here. Let's take a look at the points that we have. If you notice, the -2 and the +2 had the same y value, and the -1 and the +1 had the same y value. What does that mean? We only need to plug in for -2 and -1, and then we'll know the rest of our points. So that's what I wanted us to notice here. That way we don't have to plug in all those 5 values every time. So let's go with this one. Our equation is 4x to the second power minus 2. A is positive, it's 4. That means your parabola is going to open up. So it's going to look similar to the previous one. So let's plug in -2. Let's do exponents first all the time. I didn't do anything with the 4, so I'm just going to bring it with me. -2 to the second power is 4, so that's how we got the 4 times 4. Multiply next, and then we have positive 16 minus 2. And then we said that -2 had the same exponents as the 14, as +2, sorry, so that means that the y-coordinate for both of them are going to be the same. So you're going to have 14 for both of them. Now let's plug in -1. We do -1 square, so we get 1. Carry on the 4 with us. And then 4 times 1 gives us 4, and then we're going to subtract 2 at the end. And we said that -1 and +1 share the same y value, so we can just write it in, and we're given the one for 0, which is the vertex as well. . So on here, let's see, our lowest y value is -2, so I'm going to place my x-axis at the bottom again, since we don't need a lot of the negative exponents, negative y values. Scale the x-axis the same. Once again, I'm going to go this time by 2's, since we have to go all the way to 14. And then don't forget our -2, because we have a y value that's -2. Like I said, I usually start with my vertex, which is at 2, -2. Again, the problem gives you that information. At 1, it was +2, and at -2, it was 14. And the right side is just going to mirror the left side. So that's why we're able to use that. Connect them with a curve so that our graph looks like a U. And there it is. That's how you graph quadratics when you're not by using t-tables, when you don't have your bx part of it.